Good morning, everybody. Today we have Codeforces around 768. Div 1 round, I'll be competing. Here we go. Let's jump into it. A little underprepared here, but it's all right. We're about a minute late. Start with problem A. All right, and matching. We have n, the power of two elements containing the integers 0 to n minus 1, so all bit masks. We want to pick half the elements such that every element in the set, we find pairs. So we pair all the elements up. The sum over all pairs of the bitwise and of the elements must be k. The sum of the and must be k, okay. If there are many solutions, print any of them. If there's no solution, print minus 1 instead. Okay. So we can always make it 0. How big can it get? Probably pretty big. And this is a really off camera, okay. Are we rotated? Hard to tell. So So 4, 0, yeah, that's easy, okay. 4, 2. Oh, just pick the last one and whatever needs to match it. And then pair everything else up, huh? Yeah. So, here's the idea. We get some pens here. So if we have, let's say 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. So let's say we want 1, 0, 1. So then we do these two. That'll get us it. Now we need everything with the thing. So this one needs to be matched. And this one needs to be matched. Oh, so I just match these with each other? Yeah, because one of them is 0. And then everything else with its complement. Okay, so n has to be at least 4. Okay, and this is opposite of n and make. All right, and then for and I equals 0, I is less than n over 2 I plus plus. Okay, looks good. So then we'll say, sys out I plus this plus opposite. Three zero zero three win. Oh. Okay. Zero three one two 3102 3201 -1. Okay. Oh, this took so long. This took so long. Okay. Given an array A of n integers, find. That's not good. That's a very bad start. That's very bad. Very bad. The lights being red means we're probably not getting red after this. Oh no. Okay. each element's in exactly one pair. The sum over all pairs with the bitwise AND must be exactly k. Oh, you might be able to do 8. You might be able to do 8. Back to the drawing board. Yeah, you can do 8. Or you can do 7. Wait, what? Say k is less than n? Yeah, you can do 7. Okay. So okay, so this leaves 1 0 0 1 1 0 0 0 0 0 0 1. Okay, so this is true for 8. Okay. One and 3. Wait, this is, okay. N minus 1, this is n minus 2. We need 2 more pairs. Okay, so then we need, this is n over 2. And then we need n over 2 plus n over 4. Or, okay, n over 2 and 0. And we need n over 2 plus n over 4. And 1, oh, we already did 1. Wait, what? This can't be right. Okay, we'll do 3 and 5 then. Okay. So opposite of n and minus 1 and minus 2, 5 and 3. N minus 1 and minus 2, 5, 3. This is where Vim would be nice. Darn it. Sorry. Seven, 6. That gives us 6. 5 and 3 gives us 1, so that's 7. 0, 1. That's good. 2, 4 is good. 7, 7 is not good. 0, 0 is not good. Given an array of n integers, find a range of values, x, y. For real? Dang, dude. Okay, lots of wrong answers. Let's move on here. Let's move on to B. Find a range of values and split A into exactly k subarrays. So we want a range of values, okay, and then we want to split the array into a bunch of groups such that each subarray is formed by several contiguous elements of A. So we cut it k minus 1 times. Each element from A belongs to exactly one subarray, okay? In each subarray, the number of elements inside the range is strictly greater than the number of elements outside the range. So we find a range, and in each range, okay, gotcha. Print any solution that minimizes x, y. Okay. Strictly greater. Okay. That's a cool problem. I like it. So it's gonna get split up. And then some stuff happens. Oh, this is N, this is K. Everything's big too, huh? It is big. Is there anything we can brute force, like the lower end of the range, I guess? So you probably want to make as many cuts as possible. You don't necessarily want exactly K. You want at least K. Because if you have two, you can split them into the same. Okay. So then, do you want to be greedy? You might not. But it doesn't matter. Like the ranges don't matter. It's just the total counts that matter. Yeah, counts are all that matters. Oh, that's a cool observation. See, this is great. So now I feel smart. This is an indication of a good problem. When you figure something out, you feel smart because of it. Yeah, so the order of the elements does not matter. So let's say K equals 1. Then we need one more in range than outside. Okay, so we brute force the lower, and then binary search the upper. Let's go up to N. Yeah. Then they're gonna make us reconstruct it? That's annoying. Oh, wait. Oh, yeah, we have to construct it then. Okay. Well, at least we have the problem. Okay, so we'll come back to A. Moment. Okay. Yeah, so we have N and K. So then we'll have int array A equals read array size N. Array CS equals new int array N plus 1. Increment all this, then for int I equals 1 less than CS dot length, I plus plus CS at I plus equals CS at I minus 1. Okay. Looks good. What now? Now we need to say brute force the lower. camera, chill out. What is going on here? You alright? Also, why am I so red? I'm so red because the light's red, that's why. There we go. Now I'm very yellow. It'll adjust, hopefully. Give it a sec, okay. Okay, so this needs to do this. So int best size, or best L, yes, get min R. Best L equals 0, best R equals n. Get min R of CS and L. If R minus L is less than best R minus best L, then L equals best L, or best L equals L, best R equals R. This out, best L plus 1 space plus best R plus 1. Okay, then we need to extract the answer. Number to print equals k, well, and okay, and then also int at equals 0, and then count equals 0. Okay, so well, and to print greater than 1. Otherwise, this out at space plus n minus 1. Oh, I guess plus 1. Then. Sorry about the siren. I don't know if you can hear it. Oh, that's loud. All right. Okay, so at plus plus. Oh, I guess in start equals 0. Yeah, okay. So we need to include this. If at is greater than, if a at is greater than or equal to best L and it at is less than or equal to best R, count plus plus, else count minus minus. If count is greater than 0, then count equals 0, at plus plus, start equals at, and to print minus minus, this out, start plus 1, this is space, plus at plus 1. Yep, okay. Going until we're done. Okay, so now we just have this part. So int needed equals n over 2 plus k. Yeah, I think that's true. All right, so int left, or yeah, okay, so int min equals start, max equals n. Well, min is not equal to max, do some stuff, and then return min. Mid equals min plus max over 2. If CS at mid plus 1 minus CS at start is greater than or equal to needed, then max equals mid, otherwise min equals mid plus 1. Just it. Okay, 1, 2, 1, 2. Let's do this one at a time. Okay, 2, 2. Nope, 4, 2. Okay, 0, 1, 1 to 4. What? Why is needed 2? Should be 3. 4 over 2 plus 2. Well, that's 4. What? Okay, it's not that. It's definitely not n over 2. Okay. So n minus k. So you need k things on their own. 1, 2, 3, 4, 5, 6. Okay, so there are k of these. And then for the rest, you need a 50-50 split. So you need n minus k over 2 plus k. You need these k things. You need half of each of these. So this needs to be plus 1, I think. Oh, we need to subtract 1 from each of these now. Wait. No, you don't. So this is this should be 1, 1. So the answer is 1, 1. Okay. Wait, why is the answer 1, 1? Because we didn't subtract 1 from each of these. Something's overflowing. Oh. Counts underflowing. Okay. Five, 1, 1, 2, 2, okay. 3, 11. Seems to be true. Is it true you need 7? Let's double check that. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7. Yes, is true. Okay. This is taking so long. It's insane. Am I gonna TLE? No. Runtime error. What? Overflow. Okay. This array, we got this array. We have our counting sort. So this is the frequency of each element Yeah, so it's just the frequency of all elements, but offset by 1. Fun fact about the Olympics. Okay. The min R for some L. We're getting 4, 5? That's straight up not right. Oh. Yeah. Okay. Yes, so anyway. Okay, so if CS at n minus CS at start is less than needed, return integer.max value over 2. It's a lot of things being printed. One to 5, 1, 2, 3, 4, 5, yeah, okay. Come on. Let's actually get this problem. Please. Oh, thank you. Okay. Finally, on the scoreboard. Very far down on the scoreboard, but that's fine. Only minus 29. For how terrible this has been going, I'm not complaining. All right, we can get A. Might be worth it, actually. We're given n elements numbered 1 to n. Element I has value AI, color CI. Initially, CI equals 0 for all I. The following operation can then be applied. Wait, okay. Initially, everything is 0. The ith element has value AI. Okay. We have n value, or n elements. How big is n? Okay. We have 10 to the 5th things. Each thing has value this and color this. Initially, all the colors are 0. Okay. We can select 3 elements in order such that the colors are all equal to 0 and the first color is equal to the last color. Then set the middle color equal to 1. Find the maximum value of the sum of colors that can be obtained after applying the given operation any number of times. Okay. Not too hard of a problem, but let's first debug A. these pairs, then we'll have static pair print into A into B, turn new pair is B. Static print writer out. We'll say out dot print line A plus a space plus B. All right. Okay. Oh, so just not that. Okay, so that's fine. Okay, and then okay, so int real sum equals 0. If real sum is not equal to k, then throw null, and or not equal to make. What else do we need here? We also need to say real sum should be equal to make. Yeah, I guess everything should be used once. Out of A, out of B. Okay, so then real sum plus equals I dot A and I dot B. It is the sum of the ands, right? Okay. Okay, so this should be equal. Now we have to verify. Okay, so oops. So for 0 works. For 1, not equal to 1. Oh. Wait. What? $15, $14. This gives us 14. Then 0, 1. 0, 1 gives us nothing. We should be printing 5.3. Oh, we do print 5.3. Okay. Then 5.3. This gives us nothing. This gives us 1. Okay. Then 10, 12. Ten is 8 plus 2. 12 is 8 plus 4. Okay, so this case is what's wrong. Okay, all right, so we need to make n minus 1. In a clean way. So we need each bit duplicated exactly once. All right, how do we do this? How do we do this? Okay. That was a very unhelpful pay-per-view earlier. Okay, so we have 0, 0, 0, 0, 1, 1, 1, 1. We can get a lot of these all at once here. So this gets us all but the last bit. Okay, now we need to get the last bit. And we have this, so we also have 0, 0, 0, 1, which we have to use. Let's pick 2 more, I guess. 0, 0, 1, 1, and 1, 1, 0, 0. So if we match up these two and these two. Yeah. Okay. So this will be n minus 1, n minus 2. So that gives us this and this. This one will be 1 and 3. Okay. Then we get the opposite of n minus 1 is 1. Yeah. Okay, so then we get the opposite of the opposite of 3. And 0. Yeah, okay. What is this? Oh, this is not important. See if we got this right. Come on, come on, come on. What am I doing wrong here? Why though? Zero, 3, 1, 2. Okay. 3, 1, 0, 2. Okay. 3, 2, 0, 1. Yeah, that'll give me 2. Yep. 3. Oh. Come on. Okay, we got B. Oh, I wanted C. Oh, come on. You can do it, Codeforces. You can do it. I believe in you. Okay, moving up in the world. Holy cow, we're doing bad. Oh my goodness. Rough contest, huh? Very rough contest. Do we even want to see what the... Oh, you're next to Lightsaber. I'm also next to Happy Potato, though, so it makes me feel better. What a name. Ah, Happy Potato. Well done. Well done. What a name. Happy Potato. That's such a cheery... Oh, man, that just inspired me to go solve problem C. Let's do it. What do you say? We're given n elements, numbered 1 to n. Oh yeah, this is the color one. Okay, so something can get picked, but like, so the thing is, all three things you pick have to be 0. So, can you ever have 2 overlapping ranges? Like, you're going to have to split it. Yeah. Okay, at least we don't have to do it this time. That's nice. So it's going to be something like this, I think. It's going to be like, we have a bunch of elements. At a given position, we can match this thing with any of the things it matches with, and then like split the array and then start here. Right, and then if you match it with this, you get to keep all of these. Yeah, because there's no use to have like 2 overlapping ranges like this, right? Or is there? Maybe there is. Maybe that's not true. Yeah, it is sometimes useful. Because yeah, in this case you want these and you want this. These are both important. So once you do all of the 2's, you can then delete the 2's, right? Yeah. So we can get all of the 2's we want here. So I guess, is it just, what things can we not delete? What's going to be left out being a 0? So anything not sandwiched. And then also, every time we have a split, right? Every time there's a split, that means there are an additional 2 that are impossible. I guess the 2 breads. But I guess the breads aren't sandwiched. Is it really just the number of things not sandwiched? This isn't sandwiched. This isn't. Oh, but we can't get all 4 of these. Yeah. So, 2 impossible. I guess +1 if the breads don't match. Is that true? Potentially. 2 impossible +1 if the breads don't match. Is that... Got like a 1? Well, if the breads match, it's just +2. Yeah. Clearly, because you just fill everything. So now the breads don't match. So you have 1, 2, and then like a 1 here, and then a 2 here somewhere. So first you fill all of the ones, like you fill all of this, and then you get that, but you miss the 2. Yeah, okay. But it's still beneficial, because otherwise you would miss out on this 2. Or wait, otherwise you'd miss out on this 1 anyway. Yeah, so you still want maximal sandwiching. Okay, so I think we can use this to solve the problem. I think we're good. Do we need anything else? So we find I guess the fact that there can be splits is annoying. I guess we just have a stack of elements. Yeah, we can just have a stack of elements. And then keep popping. Yes, okay, so we have some sort of stack to find the components. So now we have all of these components. Once we have the components, then what? Then we do some stuff. Oh, then you just need to see if the breads match. So yeah, so match, then just like get middle, all middle. Otherwise, middle -1. Okay. Ooh. Yeah, we can handle it, I think. Do we want to do some examples here? So, yeah, let's say we have 1, 2, 1, 2, 7, 4, 7. I wonder if this was intentional, Boeing 747. So then we have, okay, we have 1, 2. Then when we get the 1, we union these 3. Then when we get the 2, we see this one ends too early, so we union these 4, which is a bit messy, but that's fine. Then we have the 7, 4, and then we read the 7, we union these 3. Okay. So we have these 2 stacks. This gives us 2 minus 1. This gives us 1. right? Next, 1, 2, 3, 2, 1, 3, 3, 4, 5, 5, 5, 4, 7. All right, so we get, where are the stacks? We have, this is one link here, here's another, here's another. So we'll get these 3 plus 1, 2, 3, 4, 5, or wait, plus 1, 2, 3, 4, 5. So this is 5 minus 1, this is 3. It's 8 minus 1, yep. This might be the quickest problem I'm solving in this entire contest, to be honest. But we can do it. And stuff between 1 and n. Nice. Okay. Then we need to say okay, so we do this. Cool. What now? Now we need the components. I mean, my pair is an A. Nope. Okay, so when do we add something to the end? So if, oh, this is not gonna work, for I equals 0, if first index of a at I equals I, then stk.add last, new pair I to I. Okay, otherwise, yeah, so we have this element here. Otherwise, we need to say, we need to remove first index of a at I. Okay, so while stk, or well, I guess not, stk dot is empty, begin equals I, and stk dot peak, peak last dot b is greater than or equal to target. It shouldn't be equal. It can be equal if it is what we're going for. Yeah, okay. Greater than or equal to target, then pair removed equals stk dot remove last, begin equals remove dot a. Okay, so we'll keep popping stuff off till we have everything we need, and then we'll say stk dot add last. What just happened? Is my computer still going? I just locked my screen. Okay, that was kind of wacky. Add last, new pair of begin by. Okay, so we do this. Now we have our stack. So for pair p in SDK, if p.a equals p.b, then continue. If p.a equals a at p.b, if the beginning is equal to the end, then ans plus equals p dot b minus p dot a minus 1. Otherwise, ans plus equals p dot b minus p dot a minus 2. Three. Zero, 1, 2, 3, 4, 5. What the heck? Ah! Plus begin plus I. What is going on? Ah, someone's calling me. I don't have time. And Eclipse is broken. Okay. It's just the most chaotic. It's the world trying to stop me from solving problem D. That's what this is. Come on, Eclipse, you can do it. Whoever lives in Wisconsin who's calling me, I don't have time right now. Okay. What's going on? We need sample 1, adding 0, 2, 0, 1, 2. That's right, adding 0, 3. Chill out. Okay, Monogon. Thank you. Give me just a minute here. 0, 1, 0, 3. That's right. Okay, 4, 4 is right. 0, 1, 2, 3, 4. 4, 4. Why would it be printing that here, though? Ah, I'm terrible. Horrendous. Okay. What's getting printed? All right. On to problem D. We have an array A of n integers and a set B of m positive integers. Okay, A isn't necessarily positive, such that, come on, Codeforces. and a set B of m positive integers such that each one is less than n over 2. We answer pretest 3. For real? First non-sample too. How is that the case? Okay, let's do some testing here. They're all equal to 0. Yeah. So here we get one of these. Yep. What if we have 5, 2, 1, 2, 1, 2, and we should get 3. Yep. Okay, what if we have 6? If we have 3, 1, 2, 1, 2, 3, should get 4. Okay, what if we have 1, 2, 3, 1, 2, 3? Can you do better? I don't think so. So this will be 3 again. Okay. Is it ever possible? Yeah, is it ever I guess, how would it be possible to do something other than one better than the best? Certainly they're independent. Yeah, they're definitely independent. 7 things. So we can get 1, 2, 3, 4, 5. So we get 4 of them. Can we get 4 of them though? So maybe 6 for this. Can we get? We can't. I'm too good here. Yeah, 1, 2, 1, 3, 2, 3. So if you're only 1 thick, if you're a bridge, then you need to keep both of your ends alive. Or you need to keep one of them alive anyway. Well, yeah. Why do we want to keep the 2s alive? Because they'll cover at least 2 things. Not necessarily true. They may only cover 1. Okay. Interesting though. So it really is what we care about the number of bridges. So this has 2 bridges. So I think this is very different from this. Yeah, I guess let's see why. So I guess at this point we're not getting D. Yeah, D is not happening. Okay, so for 1, 2, 1, 3, 2, 3. You have to leave both of these intact if you want to paint the 2s. So you can get the 2 2s, or you can get the 1 and the 3. So I guess let's say we went left to right. So we have 1, 2, 1. So we could paint the 2. And then we have a 3. And then we have a 2. So we want to use the 2 to paint the 1. So we paint the 1, unpaint the 2. Then we paint the 3. And then we have another 3. We want to use this to paint the 2. we paint 1, 2, 1, 3, 2. Yeah, so we paint this, this, and this. Okay. So is it true every time we have a necessary bridge? Necessary bridge subtracts 1. Excuse me. Okay, let's verify 1, 2, 3. 1, 2, 3 doesn't have that issue. Yeah, you can just get rid of the 2's right away, and then it's fine. Then you still have to, you can only get one of the other 2. Okay, so now we have, or now I guess we just need the real things, right? Only the first and last matter of each number. So array deck, or I guess just an array list. Integer. Real, new array list. So yes, okay, so if, oh, this isn't true. We can't do this. All right, how do we solve this problem for real? Let's put our thinking caps on. Need more paper. So we need to know, am I agreed on the number of useful bridges? Yeah, because every time, yeah, so it's just the number of useful bridges. So I guess, what do we do here? So we need the number of useful bridges, and we also, I guess, need the number of sandwiches, or I guess total cover, like number of like sandwich interiors. I guess this is just total sandwich size. Okay, so this we can just use a bit if we need. This we already have, so it's really not that hard. Microsoft, okay, I was gonna say, if you make me do one of the insanely annoying two-factor authentication things, I would lose it. Bit. Why is this scrolling so wonky? What have I done? Okay, scrolling is broken. Eclipse is not your day. Okay, so we need the number of useful bridges. So we want update read. Okay, so we want void range update and then int point query. So range update int L, int R, int by x. So this will be return read at x. This will be update L or update R by update, wait, no, update L by update R plus 1 by minus 1 or by minus by. So then what do we need to do here? So we have a new bridge. Okay, so if I last index of a date I, and continue. I don't think this should break anything. Yeah, okay. So now we have the last index and the first index. We have our bridge. Oh wait, we don't even need to do it in this loop here. Yeah, okay. So then, let's do it here. Okay. No. Okay. So then for n equals 0 less than n plus plus, if first index of I is not equal to, or is equal to last index of I, and then continue. Otherwise, we want to say we want to know, is there a 1 in this range? Okay, so it's a little bit more complicated than I thought, but still not bad. Okay, so then we do bit.range update from first index at I times 2 to last index at I times 2. By positive 1. All right, so int array csn1s equals new int array n plus 1. Equals 1 less than n plus csn1s at I equals csn1s at I minus 1 plus bit.query, point query, I minus 1, this equals 0, or equals 1. If it does, then we add 1, otherwise we add 0. Okay, then we do this again. So int start equals this. Oh, okay. Yeah, this is going to be n times 2, I guess, minus 1. I is less than csn1s, I plus equals 2. That makes this a useful bridge. Yeah. Okay. Zero is useful. There are other ones that definitely are too. 0, 4. Yeah, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 0, 1, 2, 3, 4. 2, 8, 2, 3, 4, 5, 6, 7, 8. And then 6, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. That's right. Okay, so not helpful. Point query of I equals 1. Okay. One is useful. Okay, we got the right useful things. Everything's useful. Okay, the answer is not 1 though, it is 2. So, where are we screwing this up? Yep. Okay. 2, 7 looks good. Ugh. Rough contest. Bro, I can answer test 3 again? For real? But I fixed it. Wait, I thought I fixed it anyway. It's a completely different solution. Have I just... Okay. 6. So this is 3, yeah. This one's 2. Wait, what? I fixed it. Is it not the number of useful bridges? My number of useful bridges wrong? Why? Not cool. Not cool. Oh, can the bit be wrong? No. Most of the 5th. guess we can try. Okay, so this is 2. That should be 6. That should be 8. How is this wrong? I have no idea. Ugh. Dang, dude. Man, that's depressing. I'm really not getting C. Why is it wrong? I don't know. Yeah, no idea. No idea. No idea. Well, how'd I do? Pretty bad. Still next to happy potato though. I'm a sad potato at the moment. I'm a pretty sad potato. Should I have written a brute force for this instead? Not easy to brute force. Yeah, I guess I don't really know. So input is just an array of integers. The brute force is, I guess it's a 2 to the n. Yeah, so it's not bad. Not bad at all. Yeah, I don't know. Okay. It's kind of depressing. I guess I can talk about A and B, but I don't know, not particularly useful. I'll still upload the screencast because I do that, but it's just, ooh, yeah, not helpful, not helpful. All right, let's talk about them. So Problem A, and matching. We have a set of n numbers in an array where each one occurs exactly once. And we want to pair up all of the elements, so every element's going to be in a pair. We also want the sum of the ands of each pair to be k, which sounds a bit complicated, but basically for each pair, you and their bits, so you look at the bits that those two elements share, and you want the sum of those bits to be k, or the sum of those ands to be k. So the key observation here is that if the sum that you're looking for is anything other than just the full bit mask, you can just do this with one pair. You can just take the full bit mask and whatever you're looking for, and that'll get you the sum. Then you just have to find pairs that have an and of 0. So that's pretty easy to do. For everything else, or I guess the only other case that's left is you want your and to be that thing. So let's do an example here. Let's say you're going for like let's say you've got 3 bits. So you've got these 3 bits. So you've got 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, and then all of these, but with a 1 in the beginning. So here are your 8 bits. Your 8 masks that you need to make into pairs, and maybe you want a sum of this. So what you can do is you can take this one here and this one here, and that'll get you the sum that you want. So now you just have to focus on using everything else. So in this case, you could get this, and then the opposite of it. Well, okay, the tricky part here is that we want to match everything with the opposite of itself, but this one and this one already have their opposites being used. So since one of these is empty, we can always match this with this. These will have an and of 0. So that'll be one way of handling this, and now we can match everything else with its opposite. So 0, 0, 1 matches with this, because these are opposites. And then these two match with each other. So that's the idea for that. So this matches everything up, and then our and is entirely in the first part. That handles everything if the and is, if the and is not exactly equal to this biggest number, that'll handle it. It'll also handle the case where the and is 0. You just match 0 with the biggest thing, and then you're good. Although my code kind of special cases that for whatever reason. Well, I guess 0 is a bit different, because you don't, you only just match the 2 up alone. You don't have to match 0 with this other thing. So depending on how you implement it, you might have to be careful with the 0 case. The only part left is, can you make the bitwise and of n minus 1? And you can't using that method, but when n is bigger than 4, when n is a power of 2 bigger than 4, you might be able to. So let's talk about that. In particular, when n equals 8, in this case, you can actually do it. So how do you do it? Well, let's get rid of this here. First, we're going to start getting everything but the smallest bit. So we'll start with, what we're going for is this. So we'll start with, we get that. And we can do that really easily with just this and this. So this gives us everything but the last bit. Now to get the last bit, we're going to need this 1 here. So we'll take the 1. And then we want something with this last bit. So we'll just take a 3, because it's the next smallest thing that has this last bit. So now we also want to match everything with its inverse, but we can't totally do that. In particular, we don't have to worry about 1 and its inverse, but we haven't used 0, and we also haven't used the opposite of 3. So we can do 0 and then the opposite of 3, and this will then work for everything else. This works when n is 8. It also works when anything is bigger, right? You'll just add, you'll add a bunch of 0s here, and then a bunch of 1s here, some 1s here, some 1s here, some 0s here, and some 0s here. That's how it works for like a bigger number. But it does not work for n equals 4 because this number here and this number here would be the same. So it's just not possible. So yeah, that's the only case where the answer is impossible. It's possible in literally every other case. That's valid input. Yeah, so that's problem A. Pretty easy. I mean, honestly, A and B were both very easy. I just kind of choked. Or I don't know, it's not choked. There wasn't really that much pressure. The pressure certainly wasn't unusual. I just did poorly. Like I had cases I didn't consider in A, and then I had a bug in B, and then I have no idea why I'm wrong with C. But overall, just not a very good contest at all for me. For B, let's talk about B. We have an array of n integers. Yeah, we need to find these values and split it into some groups. So the first observation here, which is pretty important, is that the order of the elements in the input doesn't matter, which is it makes the problem way easier. The reason for this is because we just have some good elements and some bad elements, and we need to make sure that all of the groups have more good elements than bad elements. So what we can do here is just say, like, we'll greedily cut off the groups as soon as the group has more good elements than bad elements. We can do this because, like, we can later on we can combine two groups if we need to, right? So we'll have like the group as soon as it becomes valid, we'll cut it off, and then we know later on has to be valid if they're like good things later on in the array, or if there are enough good things later on in the array. So we'll make the cuts as soon as possible, and then all that matters is like in our last group we have to wind up with, because we're never going to use too many good things earlier on, right? Because we make the cut as soon as we're allowed to. As soon as we have, if we get a good thing and that's the first thing, we'll cut it right there. We just have to make sure in the last group we wind up with at least as many good things as possible. So yeah, so then that's, I guess, like the reason why the order doesn't matter. So then the question is like, what is the minimal range that you can do to define what's good and what's bad? And the trick for that is we're going to brute force like the start point of the range, and then we just need to find the end point of the range. So yeah, we brute force the start of the range pretty easily. It's between 0 and n. It's one of the elements they give you. And then you can binary search the end of the range. And if you know how many elements are in the range, then you know whether it's enough or not. In particular, what you need is for each group that's left over, you need the one element in the majority. So you need k of those elements. You also need every other bad element to be paired with a good element. And that just means of the ones that are left, of the n minus k that are left, you need at least half of them to be good. So formally, you need k plus n minus k over 2 ceilinged good elements. So yeah, then you can do that with a binary search. What does that look like? Oh, I guess I should have shown my code for A. So yeah, I guess we'll show that real quick. Sorry if it's a little too small. Should be kind of good though. So some brute forcing nonsense. This is the case where it's impossible. Otherwise, if this is the impossible case, or this is the difficult case, you do these two, and then the opposite of 3 and 0. And then if it's not 0, you just do this. And then I pair the unused things up with their opposite right here. This is to verify that it actually works. Okay, that's A. For B, what does the code look like? Yeah, we already solved the problem. So what does it look like? Read in the A, get counts of the frequency of each thing. And this is like a cumulative sum of the frequency. So that's what's going on here. And then this is the way I implement this is pretty confusing, but I'm going to subtract 1 from everything in A, but I don't do that till later on. I do that down here. So yeah, so this like frequency stuff is like offset by 1, like a frequency or like a cumulative sum should be. But I do it in a very hacky way. Maybe that's why I have wrong answers, because I'm spending time doing stuff that's clever rather than just doing it the simple way, a little bit longer, and then understanding everything that's going on. But yeah, there you go. So build the cumulative sum array, build this prefix sum array, and then the frequency of the prefix sum. Okay, so now I have, what do I have? Yeah, I have the best L and best R, and I want to minimize this range. So I brute force the L, find the first R that works with a binary search, and then check if it's the new best answer. Then I print the best answer and extract how to do it. This just greedily extracts the first group I can, and then prints the last remaining group. So a bit messy. Okay, how does the binary search work? So first you have to make sure it's possible. If it's not possible, return some massive value, so it's not the best. But if it is possible, that means we don't quit here and we do this for loop. So if there are enough elements in this range, then that means this range is big enough. Otherwise, that means this range is too small. So yeah, and since the left endpoint is fixed, these are the min and max right endpoints that we're binary searching. Yeah, that's B. Okay, problem C, I don't know how to do. I'm not gonna explain my solution because apparently it's wrong, but the general idea is that we can like, if we take the first and last element, we can like combine that range into one thing. But then there are some things, or like sometimes you can't do that, and the only time that occurs is when you have like a bridge of one element. So if like you have an element that you need to use in one position, then you like have to keep the second version of that element alive, which means it's going to be an element that you can't color in. But like I said, I don't think it's too helpful for me to discuss it because it's wrong anyway. I'm very interested in why it's wrong, but that's something for me to figure out on my own. Okay, thanks for watching. That's all here. This is me going back into the depths of rating. How much am I gonna lose here? Almost 100, jeez. Man, this is the lowest I've been in over 2 years. Maybe not over 2 years, almost 2 years. Probably over 2 years. What is this? 220? Okay, yeah. In just about 2 years. It's the lowest I've been. Ooh. Okay. Time to start training. Gotta earn it back, right? Anyway. Back to master. Not a fun day, but you know, if you don't have valleys, you're not gonna have peaks, right? Unless you're tourist. Speaking of which, did tourist do this round? Hang on, let's check. He did. Oh no, 9th place. Sounds like he's losing rating though. Tourist, how do you do? How do you do? How do you do? Okay, I don't know. I guess we'll see. I can't imagine 9th place is going to bring him up. The reason I'm so interested is he's incredibly, like, look at this. Recently, he's gotten incredibly close to 4,000, which would just be insane. But yeah, best of luck to him. He's already got 40,000 friends, so getting 4,000 contest rating would be incredibly impressive. Anyway, thanks for watching. Have a great day, and good luck in the Div 2 in 3 days.